Hey everyone, so my name is Zach Vines, and in the previous video, which I'll link in the description, we kind of just provided the overall base format for what you write down whenever you're setting up a hypothesis test for two sample hypothesis tests. So whether or not you're dealing with an independent samples test or a match pairs test, you know, the definitions of those and everything are covered in the previous video with the link in the description. But we want to give you a couple of examples to actually figure out how you would set up these hypotheses given the base level format we provided you. So example one, we just have that we have an instruction manual, like a new instruction manual for a desk. And we're hoping that with this new instruction manual, it takes less time to assemble this desk than it did with the old manual. So it's a better manual, takes less time, probably less redundant, less steps, so on and so forth. So the hypothesis for whether or not the new manual is effective. Well, remember whenever we're setting up hypothesis, there's two ways we can really go about it. One is that we can match what it is we're wondering about with the alternative hypothesis, meaning that this sentence right here, is the new manual effective? That is the mentality that we're going to put in for the alternative hypothesis. The other way is that if you have the sample information for your first group versus your second group, you want to exclude the sample proportion or the sample mean, if you're dealing with a mean or proportion, from your null hypothesis. So there are two totally different ways of doing it. We're going to talk about just matching what you're wondering about with the alternative hypothesis. It should work out either way, but we don't have the sample information, so we couldn't do it the other way anyways. So essentially, if I'm wondering whether or not the new manual is effective or not, first I have to identify when we're dealing with mu1 and mu2, which in the previous video, this is the standard format whenever we're dealing with these mean-based tests. First of all, we are dealing with an independent pairs test, not a matched pairs, because what's going on is that we have a group of people who are using the old manual to assemble the desk. Then we have a totally separate group of people with the new manual who are assembling the desk on their own. So we have two different groups, each with their own specific treatments. So it's not a match pair where it's like a before and after on the same group where we introduce a treatment. It's two totally different treatments. So on the previous video, we're going to fall under the independent pairs testing. It's going to be a mean-based problem because we're talking about the average amount of time it takes to assemble this desk, so it's not proportion-based or anything like that. And then when we're talking about maybe one-tailed versus two-tailed, there's going to be a one-tailed test. So I'm wondering if the new manual is effective. That would mean that the new manual takes less time to assemble the desk than the old manual did. So we're concerned with one direction only, it being more effective or taking less time, and thus it's a one-tailed test. So we know that we're going to talk about the difference between the two, and as far as the number we put in right here, it's going to be 0 instead of like a number they actually give us. And the reason we're saying that is because let's think about it this way. If mu1 represents the mean amount of time it takes to assemble the desk under the old manual, and mu2 represents the mean amount of time it takes to assemble the desk under the new manual, when you take the difference between the two and compare it against 0, if mu2, let's just say, is greater than mu1, meaning it actually takes more time to assemble the desk under mu2, then if you take a bigger number and subtract it from a smaller number, it's going to give you something that's less than 0, right? So that's just talking about how we can plug this in and why that makes sense against 0 right there. But to actually sort of answer the question directly, so we're wondering whether or not the new manual is effective. Well, if the new manual is effective, it takes less time than the old one. So if new is 2 and old is 1, we're just categorizing which one falls under which mu, essentially, then mu1 would be a bigger number because it takes more time to assemble that desk based on that manual. Then mu2 would be a smaller number because it takes less time. So what I'm wondering about is going to be matched to the null hypothesis through mu1 being a bigger number minus mu2 being a smaller number. That would mean that the difference between the two is greater than 0. You can double check that by just making up any number where as long as the big one is bigger than the small one, it makes sense. So if this is 10 and this is 5, 10 minus 5 is greater than 0, right? If it was swapped the other way around, it would be less than 0. So it's pretty much just matching up what it is we're wondering about, mapping it to this mentality right here where you take the difference between the two and compare it to 0 to see which one is bigger, and then matching that straight to the alternative hypothesis. So we're matching that to the alternative, thus we flip that logic for the null hypothesis, so it's less than or equal to 0, and that is the hypothesis setup for this example. So let's go through a couple more. Okay, so now this one is essentially 3 different examples, but I wanted to give you what's basically the same situation, but show you how the hypotheses differ based on exactly what they're asking about, and that can kind of give you more difference between a one-tailed test and a two-tailed test, and then the fact that what you put in for this number isn't always 0 because the only example we've done so far. So let's just go through it in order. So when we're talking about this one right here, we want to see if the average hospital bill between 2 towns are different. So let's kind of go through the steps to drill down from the previous video, sort of what base format we're walking into for the hypothesis test. So to start off with, we are dealing with a two-tailed test right here because we're wondering whether or not the hospital bill between the 2 towns are different. Not whether or not it's greater than 1 or less than 1. We're just wondering, are they the same or are they not the same? And it makes perfect sense that when we're doing that, we're saying that it's equal to 0 or not equal to 0. Because let's think, if they were the same, then if I took mean 1 minus mean 2, they're the same number. You take one minus the other, that's 0 because it's the same number. You take one number, subtract itself from itself, and that's going to be 0. And then it would be not 0, meaning it's just anything else. They're not necessarily the same number. So it is going to be a mean-based problem because we're talking about the average bill, so not a proportion, not a part out of a whole, but just the average dollar value of that. And that's how you set it up right there, knowing that it's a two-tailed test, knowing that it's a mean, and knowing that we're wondering if they are the same. We're comparing against 0 because if they were, the difference between the two would be 0 right there. So it's just simply mu1 minus mu2 equals 0, mu1 minus mu2 does not equal 0, and that's how you set it up if it's a two-tailed test. So let's talk about this situation, which is the same but slightly different, and I'm formatting it to create a one-tailed test instead. So what if I wanted to see if the average hospital bill for town 1 was greater than the hospital bill for town 2? So here I'm not talking about are they exactly the same as one another. I'm wondering just is one greater than the other? Is town 1 greater than town 2? So the greater is that key word to let you know we're talking about one direction only. So it's a one-tailed test. It's still a mean-based problem, so you know we're going to use mu1 minus mu2. And in this case, we're still going to use 0 because, again, if I'm just wondering is one greater than the other, not by a particular amount, but just is one greater than the other, then if I compare it against 0, that gives me the benchmark I need, because if one is greater than the other, then the difference between the two and whether or not that difference is positive or negative lets you know whether or not one is greater than the other. So again, we're going to match what it is we're wondering about to the alternative hypothesis. So if I'm wondering if the hospital bill for town 1 is greater than the hospital bill for town 2, you can see that in my alternative hypothesis, mu1 represents town 1. And if that is a bigger number than the average for town 2, then if I took town 2, a smaller number, from town 1, a bigger number, it would give me something that's still greater than 0. So that's how you set up the alternative. You simply flip that logic for the null hypothesis, and you're good to go right there. So finally, what if they weren't wondering whether or not one was just simply larger than the other one, but let's say I had a good idea that one was greater than 2, and I wanted to hypothesize about the exact difference. Like let's say I said the average hospital bill for town 1 is $1,000 greater than for town 2. Then I don't necessarily put a 0 right here because the difference that I'm analyzing isn't just based on which one's greater than the other, and thus the relationship with 0 would let you know that because it's either positive or negative, but it's talking about in relation to a specific number. In that case, you just whatever, you know, in this case we said 1,000, you would plug in 1,000 for x right here, and you're saying the difference between the two, its comparison to $1,000 is what we're wondering about. So that's sort of how you set that up from the get-go. And if it's just wondering, is one greater than the other, you compare it against 0, because if one is greater than the other, the difference between the two is either going to be a positive or a negative number. So either greater than 0 or less than 0, and that tells you what you need to know. But if you're wondering about a specific numerical difference between the two, you simply put that in for x instead of 0. So if they specify, put it in. If they don't, it's going to be 0. So let's go through one more example. All right, so for our final example, this one's going to be a little bit different than the previous ones, because for the previous ones, what was going on was we had 2 different groups, each with their own treatments introduced to those specific groups, and we analyzed the difference between them, kind of ran data on it, and hypothesized about one minus the other, which one might have been bigger. What's going on here is we're actually dealing with a matched paired sample, because what's going on is we have one group that we're introducing a treatment to, and the data that we're running on it is what we're tracking like whatever it is. In this case, it's going to be heart rate. We'll get into it in a minute. But what it was before the treatment was introduced and what it was after the treatment was introduced, that's lumped together into one D bar, which is the mean difference between the before and after. And then we compare that based on a hypothesis. So let's talk about that real quick. What's going on is that we're wondering what is the effectiveness of a commercial based on heart rate. So what we're wondering about first just is the commercial effective, which essentially the way someone would be wondering about that is, did your heart rate increase upon viewing the commercial? So it's going to be one person that we are monitoring their heart rate on. Before the commercial, they have some heart rate. As the commercial is going on and after the commercial, their heart rate may change. And we're going to see the difference between the two. So in that situation, we know it's match paired because of the nature of the before and after treatment being introduced on a single subject. So is the commercial effective? Just wondering, is the heart rate going to be higher? Well, remember, what we're wondering about is what we match with the alternative hypothesis. So if the heart rate is higher, that means that the average difference of the heart rate before versus after the commercial would be something greater than 0, that it was an increase in the heart rate. So it's simply mu d is going to be greater than 0, and then you flip that logic, mu d is less than equal to 0 for the null and alternative hypothesis, and that's how you set that up. So it's fairly simple, but again, they're not always wondering about just simply is one greater than the other. In that situation, you would use 0, but sometimes they're wondering about a specific measurement of that difference. So maybe they're not thinking the commercial's effective if it's just simply a little bit higher, because if it's 1 beat per minute higher, odds are you weren't that much more excited by it. So maybe they use a different threshold. They say, okay, if the commercial raises your heart rate by more than 5 beats per minute, then we think that that's adequately exciting, or that it's an effective commercial based on that benchmark. So the way we would set that up is pretty much the exact same thing, except instead of wondering about its relationship to 0, which would simply tell us if it increased or decreased, we're wondering about a specific increase by more than 5 beats per minute. So what we're wondering about, match it with the alternative hypothesis. So it's just mu d, the mean difference in the heart rate, is something greater than 0, so that's the alternative. Then you just flip that logic. It's less than or equal to 5 for the null hypothesis. So thank you all for watching. I hope that helped out. If you haven't looked at the previous video for the base formats, this is probably going to seem very confusing, so definitely look at that. Links in the description below. But these should give you a few examples so you can sort of tie that base level format to a few examples to really solidify your understanding. So thank you for watching, and I hope that helped out.